Imagine now that we want to try and implement some of these monadic operations, like adding a constant to every pixel or to multiply every pixel by a constant. One way to do this would be to write some code with some nested loops that step through every element in the matrix and performs the monadic operation on them. In MATLAB, there's an easy way to do it, and it's a technique in MATLAB that's referred to as vectorization. Consider that we have a matrix with n rows and m columns, and we have a scalar. And in the middle we have a number of standard arithmetic operators, plus, minus, times, divide, and so on. If, for instance, we use the addition operator, the plus symbol, and we add the matrix to a scalar, the result will be a matrix. And what MATLAB is going to do is to add the scalar to every individual element of the input matrix and assign it to the corresponding element in the output matrix. So we don't have to write loops to go through and add the scalar to every element of the input matrix. MATLAB will do it for us, and we use the shorthand notation of a matrix operator and a scalar. So we can add a constant to every element in a matrix, subtract a constant, multiply, divide, raise every element to a power, and so on. We're going to demonstrate this now with a real example. We'll start by creating a matrix. We'll call it M, and its elements will all be integers, and they'll be integers between 1 and 10, and the matrix will be 4 by 4. We're going to use MATLAB's built-in randi function to create this matrix with random integer elements in it. Now I'm going to add 1 to that matrix, so we're adding a matrix, a 4 by 4 matrix, to a scalar. And what MATLAB's going to do is add 1 to every element of the matrix. Similarly, if I multiply the matrix by 2, we will see that every individual element in the matrix M has been multiplied by 2. We can perform more complex mathematical functions in a similar way. We can compute the square root of M, and what MATLAB is going to do is to compute the square root of every element within the matrix. Finally, we can raise each element of the matrix to the power of 2. We use the operator dot caret, and what we see here is that every element in the matrix M has been squared. Important to note that this is very different to writing this. What this has done is to multiply the matrix M by itself. That's the same as writing that. This is multiplying a matrix by a matrix using matrix multiplication rules. Very different to raising each element of the matrix to the power of 2.